Hello everyone. Good evening. Uh, okay, so
Evening, madam.
yeah, good evening all of you. So this is the second revision session. Means week 5 to 8. Okay. Hmm. So the screen is visible, right?
Not yet, madam, but it is saying sharing screen.
Yeah. Okay. So yesterday we already discussed from week 1 to 4. We covered functions and polynomials and all, right? So today we will cover exponential logarithmic functions, sequences, and your limit continuity differentiability, right? So I am just note down these topics first, then we will discuss them one by one. Okay. So these were the most important portion from uh, week 5 to 8, right? So we know in the last session also we covered what a function is, right? So polynomials are a particular type of function, and so also exponential, logarithmic, they are also type of functions, right? So what was the exponential function? What was the definition of exponential function? It was in the form a to the power x, right? Where a was greater than 0 and a was not equals to 1, and the x was from real number, right? So what was the domain and codomain of the exponential function?
Solve real number.
The real number, right? Maps reals to reals.
Reals to what is the range?
0 to infinity.
This, right? So in from this range to form this domain, from this domain to form this range, our exponential function was invertible, right? So if for a we had two different choices, either a can be in this interval 0 to 1 or a can be greater than 1, right? So there is no meaning. If I take a equals to 1, then our function will be f of x equals to 1 power x, that means 1 itself, right? So it will be a constant function, right? So in that case, our function will not be an exponential function. So we avoid to write the base as 1. So we will take two different boundaries. First, a can be in the interval 0 to 1 and it can be greater than 1. And we know that how is the graph if a is from 0 to 1 and if a is greater than 1. We had two different type of graphs, right? So if a is greater than 1, then we had this type of graph, right? And if a is in this interval 0 to 1, then we had this type of graph, right? This is correct, right?
Yes, ma'am. Correct.
Okay. So for A in this interval, we have a decreasing graph, and if A is greater than 0, then we have an increasing graph, right? But in both the cases, if I take our domain as real number and our range as 0 to infinity, then we can see it is a onto function, right, on this range. And also, if I apply the horizontal line test, we can see that this is a 1 1 function. That means exponential function from r to 0 to infinity is a 1 1 and onto function. That means bijective, that means invertible function, right?
Yes.
Yeah.
Yes, ma'am.
And what is the inverse of this function?
The log function.
Yeah.
Yes, yeah.
Correct. Log base A is the inverse. So we know if F is inverse, then F compose F inverse equals to F inverse compose F if you are equals to the identity function, right? That means F compose G of X equals to G compose F of X equals to X for all X, right? That is the definition or the property every inverse function satisfies, right? So here our G is logarithmic function and A is exponential function. Sorry, right? F is exponential function. That means what? Exponential function of, that means A power log A x, that is equals to log A of A power x, that is equals to x for all x, and A not equals to 1, right? So it was a property of logarithmic and exponential function, and it is basically coming from the inverse functions, right? Okay. So because our exponential function is from r to 0 to infinity, obviously our logarithmic function will be from 0 infinity to r, right? Because the domain of a function is actually the range of the inverse function and vice versa, right? So our g, that means logarithmic function, is actually from 0 infinity to r, right? That means whenever we have a logarithmic function, we have to keep these things in our mind, that the domain of a logarithmic function is always the positive reals, okay? So you may get some questions. For that, you have to find the domain of a function, of the logarithmic function or exponential function. In that case, you have to use the basic thing, that the logarithmic function having the domain 0 to infinity and exponential function having the domain r. Okay. Now we can recall some formulas. So exponential, for exponential function, a power n was a power m plus n, right?
Yes, ma'am.
Then a power m by a power n, it was a power m minus n, right? Three, a power some rn is equals to a power n power r, right? And this is basically coming from this formula. Can you relate it? How it is coming from this formula? This a power rn, we can write it as n plus r times, right? Then using this formula, we can write it as a power n into a power n, right? And it is nothing but a power n to the power r. Similarly, we can write it as a power r to the power n, right? Is it fine?
Yes.
Yeah. same type of formula we can check for logarithmic functions too. So for logarithmic functions, we have first, what is log mn?
Log m plus log n
Correct.
base c.
Right. Second, is log n minus, right? So from this formula, we can directly conclude if I have this, then what will be the value of this one?
Minus log n base a.
Correct. Because log 1 is 0, right? This, right? Then log a x for r is r log a x, right? Then we have a change of base formula. What was the change of base formula? We can write it as log sum c base b by log sum c base a, right? We can write log in this way, right? So these were some formulas of logarithmic functions and exponential function. Okay, and it was the definition of logarithmic function and exponential function. So basically, whenever we will have a logarithmic function, we can have a question like you may have to find the domain or the range of the logarithmic function. In that case, you basically, if you have some complicated equations inside the logarithm, you have to use these formulas and you have to simplify the logarithmic function first, then you can find a domain. Okay, so I'm just writing down an example of a logarithmic function. You have to find the domain of this function. Okay, and you just try to calculate the domain and let me know what is the answer. Okay, suppose this is given and you have to find the domain of f. Okay. Calculate and let me know what is the domain of f. I'm waiting for 5 minutes.
Madam, x square minus 5x plus 8, madam, this inside.
Yeah, yes, plus 8.
I think the domain should be from -1 to infinity, right?
Okay.
Madam, I'm not able to proceed because x square minus 5x plus 8 should be more than 0. That much I am knowing. But when I'm trying to solve for x square minus 5x plus 8 to find the values of x, I'm not able to proceed further, madam.
Okay. So the hint is you have to use the formulas to do that. And the thing is, start with this log. This is one hint. Start with domain of this log, then come to x. Step
Okay,
by
okay.
step. Okay, I'm again waiting for some 2-3 minutes. With this hint, you just try to solve. Whenever we will have a function like that, that means logarithmic of something, we will start with the outer log, okay? Because we know that the domain of this outer log can never be less than 0, right? So that with this hint, we will start, okay? We will proceed. Then step by step, we have to come to x.
So it shouldn't be -1 to infinity because that gives me a negative value of log in the argument. So it should be x less than -1 and x greater than 6. So the thing would be minus infinity to -1 and union 6 to infinity. Okay. Let me check if this.
Okay. Okay, maybe we can then solve it together and let us see what is the. Okay. So first, as I said, that we will start with the outer log, right? And we know that the domain of logarithmic function is always greater than 0. That means the inner portion, this portion will be greater than 0, right? So this is the first thing and we will start with this. This is clear, right? This will be always greater than 0. Otherwise, we cannot define the outer log. Okay. Then in the next step, we will now like follow the simple steps. Okay. Now, what do you know? Like we want to cancel the log, right? We don't want the log in our equation because we want the value of x now. So what we will do in the next step? What should be the next step?
You
Apply until
Correct.
choose
We have
2
to take,
power 1.
yes, 2 power 1 will be greater than 2 power log 2 of this, right?
Yeah.
So the log will be cancelled out. Then we can find x square minus 5x plus 8 will be less than 2, right?
Yes.
Then
Now you can bring the 2 this side, it will become
Yeah. So
6.
domain should be 2 and
So
3. man.
5 and
Right.
3. Yeah.
Now we can break them, like
Yeah.
we
2
can
into 3.
factorize them. So 2
X
and
minus.
3, right?
Yeah. X minus 2 into X
Using
minus
the
3.
FOIL method, right? So 2x, 3x, right?
Yeah.
Then x we will take as common. So we'll get x minus 2. Then again 3 we will take as common. So we will again get x minus 2 less than 0. Right? Then we have this factor is less than 0. Right? Is it fine up to now?
Yes, madam. So
Now what
X
should
should
be the
be
next step?
X should be less than 2 or X should be less than 3.
Okay, so what you will do in the next step? What are the cases now? Possible cases.
So X can be 2.
And
Factorize,
3.
like let us say with the factorization. So multiplication
Plus.
of two factor is less than 0. That means they will have opposite signs, right?
Signs.
That means we have two different options. Either x minus 2 is less than 0 and x minus 3 is greater than 0,
Yeah.
or x minus 2 is greater than 0 and x minus 3 is less than 0. These two are only possibilities, right? If they will have the same sign, in that case, their multiplication will be positive. But we have the negative one. That means they will have different signs, right? Now, what can we imply from it? So, it will imply x is less than 2 and x is greater than 3. Is it possible? Is it possible, these two things together?
Not possible. So you go to the next one.
So this is not possible, right? That means we don't have any x which is less than 2 but greater than 3. So we will check this OR one. So here we have x is greater than
Greater than 2.
x is less than 3, right? That means from here we can find the interval 2, 3, right?
Yes.
So this will be the domain.
For the first log.
For the whole function.
Okay, we have completed, correct. Sorry.
Yeah. So this will be the domain. So that is how we will compute the domain every time. Okay, we will start with the outer log, and we have first our target is we have to define the outer log. That means the inner portion, whatever is inside the outer log, they should be greater than 0. Then we will always follow the simple equation things, and then at the end we have to conclude this with some logic. Is it clear? If you have any doubt, please ask. Is it clear the steps? How can we compute the domain and all?
Yes, madam.
Okay, maybe let us do one more example.
I found out that I did a wrong thing in the factorization, so that's why I got a wrong answer.
Okay. So you did this up to this steps, right? Then maybe somewhere you did something wrong. Maybe, right?
I did a foolish thing by taking minus 6x plus 5, and that messed out things.
Okay. So one thing we just have to keep the base in our mind. Whatever base is there, we have to take the same number. And the thing is, we have to factorize. If it is greater than 0, that means both the factor will have same sign. If the multiplication of the factor is less than 0, that means they will have the opposite sign, right? Then we have to conclude the logical things. Okay. This is a simple function. Just find the domain of this function. What will be the domain of this?
It's 1 to infinity, right?
Any other answer? I don't know what is the answer. I have to check. We have to do it similar way, okay? Similar steps you have to follow. What is coming in my mind? There should be some E involved in the domain. Anything else? Any other answer? Okay, so we will follow the same step. That means we have to define this log. So we will take this as greater than 0. Okay, so if this is greater than 0, now we have to factorize this thing, right? So what will be the factor? What
X
is the
minus 1 the whole square. X minus 1 into X minus 1.
Correct. So this will be obviously greater than 0, right?
Yeah, greater than 0.
So what should be the domain?
1 to infinity.
What if I take minus infinity to minus 1 also?
Yeah, it doesn't matter because it
Of
gets
the-
squared anyway.
Correct. So,
The union of these things.
correct. That means real line minus the point 1, right?
Yes.
This is the
because-
domain, right?
Right.
So, because from this step, we can imply either x minus 1 is greater than 0 or x minus 1 is less than 0, right? In both the cases, the square will be obviously greater than 0. So, x can be greater than 1, x can be less than 1.
How the x minus 1 becomes less than 0?
No. From here, from this step, we
Yes.
have two different possibilities. Either this x minus 1 can be greater than 0 or this x minus 1 can be less than 0.
How x less than 0, how it
So
comes? It
if-
is only greater than 0 only, no?
No, if x minus 1 is even less than 0, then the square will be greater than 0, right?
Okay.
So this is the logical connection. Either this or that.
Mm-hmm.
Okay.
Okay, I got it. Yeah.
So we are, if we take any negative number and we just square them, it will be a positive number, right?
Okay, got it. Understand.
Okay. Any doubt? So the domain, the final answer, the domain is basically real line minus 1. That is minus infinity to 1, union 1 to infinity. Any doubt in this question?
Clear.
Okay. Then maybe we can move to sequences. So sequence means we know that this is basically a panel of numbers, right? So we will collect some A1, A2, AN and so on, right? So we can also look the sequence as a particular type of function for which the domain is natural number, right? Right? So sequences we can see as a particular type of function for which the domain is natural number. Now, whenever we will have a sequence, we will have a limiting concept, right? So if we know that if n is tending to infinity, then we will check the functional behavior of the sequence function, right? So it is like whenever we checked the end behavior of any function at infinity, it is basically the same thing. That means we are basically checking the end behavior at infinity of that particular function. So if this an is tending to some number a, when n is tending to infinity, then this number a is called limit of the sequence, right? That is what we already know. Limit of the sequence an, right? So if the limit is a finite one, then we say the sequence is convergent. If so, an is convergent if a belongs to some real number. That means a is a finite number, but if such a doesn't exist, or a equals to plus minus infinity, then we will say that our sequence is divergent, right? Right?
Yes.
So thus we have two different type of sequence. One is convergent and second is divergent. So if I check the example, so for a divergent sequence, if I take minus 1 power n, so can I find any number such that the sequence is tending towards that number when n is tending towards infinity?
No, because it will keep on cycling, like -1 + 1 -1 + 1.
Correct. So at infinity, it can be anything. It can be +1, it can be -1. We don't know what is the exact number. So this is an example of divergent sequence, right? If I take simply n equals to n, then it will be tending towards infinity, right? So this is again a divergent sequence. If I take n equals to 1 by n, so is it a convergent sequence or divergent sequence?
Convergent, as in tends to infinity.
Correct. So this is tending to 0 as n is tending to infinity. So this is an example of convergent sequence, right? So we can again follow some examples. Suppose we have n equals to 1/5 plus minus 1 by n whole to the power n. So first, is this function convergent? Is this convergent? If yes, what is the limit?
1/5.
0.2.
Correct.
I mean 0.15.
So the limit is 1/5 because this term is tending towards 0 whenever n is tending towards infinity, right? Okay.
Yes, ma'am.
Then one typical example, if I have some n power 5 minus n by 2 sin n by 5. What is the limit of this sequence?
One.
It's 1.
It's one, ma'am.
Yeah. So we can take n as common. So we will get 1 minus 1/2 n power 4 plus sin n by
N power 5.
n power 5. Then 1 minus 1 by n power 4, right?
How do you get that numerator? You divide it by n power.
N power 5.
Okay.
Okay. So we are dividing by n power 5. Okay. Now this term, and this term, this will be tending towards 0 when n is tending towards infinity, right? And this is because the sine function is a bounded function. The sine function is a bounded function. it is always greater than minus 1 and less than 1, right? So we have a bounded function by some infinity term. That means it will be again tending towards 0. So we will have 1. Okay. So now we know what are subsequences, right? Subsequence is basically subset of the sequence. That means we will recollect some term from the mother sequence and this will be the subsequence, right? So for example, if I have this one, is it a subsequence? Is this sequence a subsequence?
No, the 4 is repeating 3 times.
Correct. So we cannot take the 4 twice. Okay. But we can take any like 1, 2, then 8, then 10, then so on. This is a subsequence, right? So that is how the concept of subsequence matters. And second thing is, we have a remark. If Bn, Cn, or we can take it as directly A to n and A to n minus 1. That means this is the even terms of the sequence an, and this is the collection of odd terms of the sequence an, right? Right? So if an is tending towards A, then it will automatically imply that A to n this one will be tending towards A. Okay. And if both A to n and A to n minus A is tending towards A, it will imply an is tending towards A. That means if I have a convergent sequence, then if you take any subsequence of that convergent sequence, it will be convergent to that particular limit. And if all the even sequence and odd sequence is tending towards a number, a finite number or anything infinite number, in that case, our main sequence will be also tending towards that number. Okay. So we have seen this example, right? I'm just rewriting this example, 1/5 by some minus 1 per n cube, for example. Suppose this is our n. So what is a 2n here? What is a 2n here?
1/5.
No. You have to collect the odd terms, even terms from that sequence. So what will be the even terms? You have to put 2n instead of n.
Okay, so my series here would be 1/5 plus minus 1 to the power 2n by 2n whole cube.
Yeah. Then in the next step,
Ma'am, its limit will be 1/5.
yeah, limit is 1/5. I just want to know what is the sequence, subsequence a to n.
Got it. Actually, I was telling about limit.
Okay. So this will be the positive one, right? Even terms means
Yes,
minus
yes.
1 per something even means it will be positive. So we have 2n cube.
Yep,
So it
you're
will
very
be
well.
tending towards 1/5, right? Similarly, the odd sequence will be 1/5 minus 1 by 2n minus 1 power cube, and it is also tending towards 1/5, right? So if I have this data, that means this even sequence and odd sequence is tending towards the same limit. We can directly imply the main sequence will be also tending towards the same limit 1/5. Okay.
And this is a2n minus 1.
Yes. A2n minus 1. Thank you. Okay. So sometime you may get a sequence like which is defined differently for even and odd term. Okay. Like some function for even terms and another function for odd terms. In that case, you have to use these things. Okay. That means you have to find the limit for even terms. That means you are basically finding the limit of the even sequence, and you have to find the limit of odd terms. That means you are finding the limit of the for the odd subsequence. So if they are giving the same limit, that means both even and odd sequences are having same limit. So you can directly conclude our sequence is also having the same limit. But if they are giving the different limit, in that case, we have to conclude that limit does not exist. That means if for even sequence, a to n, it is supposed tending towards some b, and the odd sequence a to n minus 1 is supposed tending towards c. So we can directly imply our main sequence an is not convergent. Okay. So if you have a definition of sequence in such a way so that this is defined differently for even and odd terms, you have to check for differently even and odd terms. If the limit are same, then the sequence is convergent and limit will be that same value. If the limit are different, then the sequence is not convergent. That means divergent. Okay. So same concept, whatever we have seen for sequences, same concept we can apply for any random functions also, right? So for functions, for sequences, we are just finding the end behavior. That means the end behavior at infinity. But for function, we can find the limit at any point, right? For function, we can find the limit at any point. So at a, if I find the limit, so we can denote it as limit extending to a, f of x equals to some L, right? And this L is called the limit of the function. If L is something finite, in that case, we will say that limit exists for function. If L is not a finite number, in that case, we will say limit does not exist for the function, right? And here we have the concept of left hand limit and right hand limit. And what was left hand limit? Anyone? What was left hand limit?
We approach the function from x going to a minus, from
Correct.
a plus minus epsilon, let's.
That means we will approach towards a, but from the left hand side of it, right? Because we are approaching up from at a from the left hand side of a. That is why we will say it as a left hand limit. And left hand side means the negative side. So we will denote it as x tending to a minus this, right? And same for right hand limit. So we will approach towards a, but from the right hand side of a, that means positive side of a. So we will write it as x tending to a positive. So if we know that if both left hand limit equals to right hand limit, in that case we can say that limit exists. It will imply limit exists at a and equals to L, right? But if the left hand limit and right hand limit are not equal, then we say that limit does not exist, right? So we can maybe see an example. Suppose limit x tending to 0, 1 minus cos x. Okay. So what is the limit of this function?
0 anyways.
0, right? What?
Is it
So-
not one?
How is it 1?
No, I don't
Zero.
know.
Zero, one.
Cos 0.
Right.
Cos
If-
0 is 1.
Zero, ma'am,
1
zero.
minus 1, 0.
Yes. So if I tend for up to 0 from the negative side, then we will find what? Cos 0 is 0, right? And cos is a even function. So minus of something is also again cos of that one. So the limit will be 1 minus 1 because cos of 0 is 1. So limit will be 0, right? But what if I take limit extending to 0, 1 minus sin x? What is the limit?
1.
1.
Right.
If you go for
But if I take limit extending to pi by 2, 1 minus sin x,
0. 1, pi by 2.
Zero, ma'am,
45
zero.
degrees. 1 minus 1 by root 2.
pi by 2 means 90 degrees.
1 minus 1, 0.
Zero, ma'am, zero.
Okay. We have some rules.
Ma'am,
Yeah.
ma'am, if limit exists both from LHS and right hand side, so that means that particular function is continuous, right?
No, if limit exists for both right hand side and left hand side, that means limit exists at that point. But if that limit can be any real number L, okay? But if this real number is particularly the functional value of the function at that point A, then we will say it is a continuous function. Okay? Okay? So here in this case, this is our function, right? And the limit is 0. What is the functional value at pi by 2? 0 itself, right?
Yes, yes, ma'am.
So this function is basically a continuous function, right? Because our limit is particularly equals to the functional value of that function at that point, right? Now,
Yeah.
if I, fine. So if I have this thing equals to L, limit extending to A, G is equals to M, then limit extending to A, F plus G is M plus M. That means limit follows the distributive laws. Limit extending to A, F minus G is L minus M. These are the formulas, right? And we have to apply them to solve. Fg is Lm, and this is the division rule. F by G is L by M, provided M is not equals to 0, right? And then we had the sandwich rule. What was the sandwich rule? Any one of you, just let me know what was the sandwich rule.
so if the function lies between like g and h, then we can say that the value of the limit of the function is between some h and some g.
Yes, that means if I have that f is tending towards A, g is tending towards A, and f less than h less than g, in that case we can imply h will be also tending towards the same limit, right? Right? This
Yes.
was the sandwich principle. So using sandwich principle, we can solve so many things, right? If I have this sine n by n, so this will be basically my less than this, right? We know that the sine function is greater than minus 1 and less than plus 1, right? So sine n by n will be greater than minus 1 by n and less than 1 by n. So we know that when n is tending towards infinity,
Ma'am, do we have equality as well?
Yeah, so you can here, if equality is there, this is a more stronger property. But if you don't have even equality, then also it is possible, right? Because if I have this inequality, okay, whenever we will apply the limit, we will automatically find the equality. Okay, that means if you have a inequality na, then that inequality, if you apply limit, there will be a equality. Okay.
Okay, ma'am.
Okay. So when n is tending towards infinity, so what will be the limit of this function sin n by n?
0.
Yes. Correct. Okay. Using the sandwich thing, right?
It's 1.
What? No. I'm saying when n is tending towards infinity. So if n is tending towards infinity, both of them are tending towards 0, right?
Yes, yes.
So this will be also tending towards 0. Okay.
Okay.
Now we have L'Hospital rule, right? L'Hospital, or sometimes we can say it as L'Hospital rule. So we have seen the division rule. If m is not equals to 0, then we can apply the division. There is no problem. But what if m is equals to 0? So for that, we have the L'Hospital rule, right? Whenever we have our function in f, limit f by g form, and if some x tending to a, if fa by ga, this is in indeterminate form, that means either 0 by 0, infinity by infinity, like plus minus infinity by plus minus infinity, right? So if this is in this form, that means in indeterminate form, in that case, we will apply the L'Hospital or L'Hospital rule. And what does the rule says? The limiting value will be same if I do the derivative of the function, right? So this is our L'Hospital rule. Now if I check this problem, 1 minus cos x by sin x. Okay. So what will be the limit of this function?
-1.
Any other answer?
No, ma'am.
Okay. So if I put 0, this is again in f by g form. And what is f of 0? It is 1 minus cos 0, that means 0. And sin 0 is also 0. That means this is in 0 by 0 form, right? So we can apply L'Hospital rule. What will be the next step?
1 plus sin x.
1
Upon-
will not be there.
No,
Sin
sin
x
Yeah.
by
upon
cos
cos
x.
x.
Sin x
Yeah.
by cos x.
Sin x by cos x.
So what will be the answer?
0.
Limit x tend to 0 tan x.
Right?
No.
So it is 0 by 1. That means 0, right? Cos x is 1 at 0 and sin x is 0 at 0. So 0 by 1 means 0. Okay. So this is how you have to use the L'Hospital or L'Hospital rule to solve this type of problem. Okay. But limit extending to 0, tan x by x. What is the value of this one?
1, ma'am.
So tan x, we can write it as sin x by cos x, right? And we have x. Now we can apply the multiplication rule, right? So if I apply the multiplication rule, so it will be tending to 0 sin x by x into limit x tending to 0, 1 by cos x, right? So we know that this limit is equals to 1 and this limit will be again equals to 1, right? So we will find the whole limit as equals to 1. Okay. Then about continuity, I just said if particularly L is equals to the functional value, that means limit extending to a, f of x is f of a, then we will say that the function is continuous. And continuity also will satisfy all the properties. That means the addition rule, subtraction, multiplication, division, all the properties we can apply for continuity also, right? So is
Ma'am,
this, yeah.
ma'am, what about differentiation by parts?
Okay.
Like in case of x cos x, we have separated it into two terms. Can we apply the formula differentiation of x cos x as such plus differentiation of cos x into x as such?
uh, can you say again?
Multiplication rule.
Multiplication rule for derivative, right?
Yes, ma'am.
I will go to derivative after continuity. Okay.
Nee, I'm talking about the previous example, ma'am.
Okay.
X
Here,
cos x. Is there another method to solve that?
no, I mean here we are taking this as our function f, and this is as the function g, right? So we have to calculate simple f dash and g dash. So f is 1 minus cos x. So the derivative of 1 is what? 0, right?
No,
And
no, ma'am.
derivative,
I'm talking about this sin x upon x cos x. The last example.
okay, this one.
Yeah.
This
So
one.
in case of x cos x, can we do derivation by
Yeah,
multiplication?
yeah, sure. This is also in 0 by 0 form. So if you want, you can also do this. Like, okay, maybe let us see. So we have limit extending to 0 sin x, x cos x. So you want to find this, like you want to apply L'Hopital rule for this, right? If I'm not wrong, right?
Yes, ma'am.
Yeah. So then the derivative of sin x is minus cos x, right? And for derivative of x cos x will be cos x plus sin x, or minus plus. Maybe I did the opposite one. This one, right? Right?
Yeah.
Uh,
Now if I just put, so cos of 0 will be 1, then cos of this will be 1 minus 0. So the answer is again, okay?
ma'am, how it is cos x minus sin x?
Cos x minus x sin x, sorry.
X, yeah, yes.
Yeah, cos x minus x sin x. Okay? It was your doubt, right?
Yes, ma'am.
Okay. So what do you think, is this function continuous or not? Is this function continuous? The last function, tan x by x, at the point 0.
No, ma'am.
So continuous means we have the limit L equals to 1, but if this is equals to f of a, in that case we can say it is continuous. But tan 0 by 0, it's not defined, right? But if I define this function in that way, if x equals to tan x by x, if x is not equals to 0 and 1 is x is equals to 0. In that case, what can we say about continuity?
Yes, ma'am. Continue.
In that case, it will be continuous, right?
Ma'am,
Yeah.
ma'am, we take a 10x formula x plus x cube by 3 plus 2x cube x power 5 by 15. Then solve it.
That means you are saying about the expansion of tan x.
Yeah.
Yeah, that is also possible way. You can also solve it in that way. So what is the expansion of tan x?
X plus x cube by 3 plus 2x power 5 by 15 plus 2x power 5 by 15.
this way something. I don't remember the exact expansion. Okay, for let's say we are taking this one also. So if I divide it with x, this is again I went to x, so it will be this, right? And whenever the number of term will increase, the degree will also increase. So if x is tending towards 0, that means this portion will be tending towards 0. So 1 will be only left, right?
Yeah.
So again, if you also use the expansion of any trigonometric function, you will find the same limit. Okay. Okay. And now we can go to differentiability. So you know that if this limit exists, if a plus h minus if a by h finitely, then we say f is differentiable at the point a, right? And we denote it as f dash a, right? So f dash a is basically equals to this thing. Now for differentiability also, we have the concept of left hand derivative and right hand derivative. So left hand derivative is, I will use this notation,
A minus H.
yeah. So minus you can take anywhere. I am taking minus here. That means no need to take minus here. Okay. Now if I take plus here, h tending to 0 plus, here we will take a minus h minus f of a h. Okay.
Man, divide by minus H.
Yeah. Divided by minus h. That means it will be basically limit h tending to 0, f of a minus f of a minus h by h, right?
Yes.
So you can use either of this definition, okay? All the definitions are basically same. You can use either of this definition. And what is the right hand derivative? Zero plus. It is like similar to the limit, right? Or you can simply write it as a is tending to 0 plus so these were the definitions of left hand derivative and right hand derivative, right? And we have the similar concept as limit here too. That means if both left hand derivative and right hand derivative exist, and if they are equal, then only we can say the derivative exists at that point. If this is not the case, that means any one of that left hand or right hand derivative does not exist. And if they even exist and not equal, then we will say that derivative doesn't exist, right? So if both equals to this equals to some number, then it will imply that derivative exists and the derivative is equals to that number, right? Now, we have a remark that whenever we have the function is differentiable at some point, it is see the screen, right?
No.
No, ma'am.
No, ma'am.
Wait. Now,
Yes.
Yes, ma'am.
so what was, yeah. So we have a remark that for a function f, if f is differentiable at a, if and only if at a the rather the unique tangent line, right? So what is the tangent line? It's basically if I have a function at a point A, tangent line exists, means we can draw a unique line which touches the curve at the point A, comma, f of A, right? So if A is a differentiable function, differentiable at the point A, then we can draw a tangent line at the point A. And if we can draw a tangent line at the point A, that means the function is differentiable. So we know that if I have a sharp corner in our function, then at that point we cannot differentiable our function because we cannot draw a unique tangent line, right? So this can be a tangent line, that can be this. So all, like, we can draw any line and this will be a tangent line at that point for that curve if I have a sharp corner. So whenever we will have a sharp corner in our curve, that means at that point, at that sharp corner, our curve is not differentiable because we cannot draw a unique tangent line. Okay. So whenever we can draw a unique tangent line, the slope of the tangent line is theta, the angle, the line making with the x-axis. Okay. And tan theta is nothing but f dash a. Okay. So we have the tangent line T is a line is passing through a comma f of a with the slope f dash a. So what will be the equation of the line?
F dash a x minus a plus f.
Using the slope intercept form, right?
Yes.
So this is the equation of tangent line. And this is called a linear approximation, right? Linear approximation of f at a, right? That means near that point, if I just check near at that point, near in a neighborhood of, in a close neighborhood of a, then in that neighborhood, the curve f and the tangent line is almost same, right? The curve is a curve, but the tangent line is a line. That is why this is a linear approximation in a near neighborhood, in a close neighborhood of A. Okay. So that is why we say the tangent line as linear approximation of the function f near a close neighborhood of A. Okay. So if I want to find the value of the curve near A, then we can find the value of the linear approximation near A, and they will be same, like either same or approximately same. So for derivative also, we have some formulas. First, the addition rule. So if I have to calculate the derivative of f plus g, that means f plus g whole dash at some point is g dash. Same for this. But in the case of derivative, the multiplication and division rule is slightly different, right? So what is the multiplication rule? Anyone? What is the multiplication rule?
F dash A G A
Dash.
F dash of A into G A plus G dash A F A.
Correct. What is the division rule for derivative?
G of f prime minus f of g prime by g squared.
G of
G of f
GA
prime
into F dash A minus
Minus
G dash A into FA upon GA
A.
square.
correct. So for derivative, the multiplication and division rule are slightly different. Then we have the chain rule, right? And chain rule is for composition of function, right? So what was the chain rule? If I have the function this, so what will be the derivative of this function at the point A?
should be g prime of A and f of
First,
f prime g of A.
first we will calculate f prime of A, right? At g of A, right?
Right.
Then we will find the derivative of g, the inner function, right?
Yes.
So this is the chain rule for derivative. Okay. Okay. So these are the main concept. We can now solve an example. Suppose this is our function f, okay, and we have that the function is continuous. Sorry, this is not plus, this is x. Yeah, you just calculate and let me know what should be the value of this mn.
M and N equal to 5.
You have to find m, n, and p.
Okay.
We have given the hint that the function is continuous and differentiable at 0.
A N is 1 and P is 2, right?
I don't know. We have to solve. Is there any other answer?
I'm solving for M.
Okay. What about others? What about others? Okay. So we have it is continuous. That means limit. First of all, we know that limit exists, right? So left hand limit will be equals to right hand limit at 0. So what is left hand limit at 0? What is the left hand limit at 0?
It's N plus 2.
Correct. And what is the right hand limit at 0?
P plus 1.
How do you say it is n plus 2?
Okay. So left hand limit means you
Okay,
have
okay.
to
Got it,
calculate
got
the
it.
limit for the function n e power x plus 2. So you can directly put the value, right? And what is the functional value at 0? It's
3.
3, right? Now this continuous means this n plus 2 will be equals to p plus 1
Equal
will
to
be
3.
equals to 3, right? That means our n is equals to 1, p is equals to 2, right? Okay. Now we have the function is differentiable at 0. So we have to use the definition of differentiability at that point, right?
From there we get condition for M.
Yeah.
M is 5.
Okay, let us check. This is what we have, right? Just the definition. I wrote the definition only. So differentiable means the left hand derivative and right hand derivative will be equal. Now, if f is tending towards 0 from the negative side, that means we will use this n e power x, and the value of n is 1. That means e power x plus 2. That means e power h plus 2.
So M is 5.
F of 0 is 2, right? So, hmm. Five x. The value of p is 1. That means 3 minus 2 by h. Right? Is it fine up to now?
Yeah.
This will be h.
F of 0 is 3, right?
Okay, yeah, correct. That is why f of 0 is 3. Now it is fine. So the next step we have.
Right hand side as well.
Ma'am, p value would become 2 na?
What?
P value.
No, this will be 3, right? F of 0, we have to find the value of f of 0. F of 0 is 3. This, right? So this is e power h by h minus 1, that is equals to limit h tending to 0 plus 5 will be there only, right? Okay, so limit, this is in 0 by 0 form, right? So we can use the L'Hopital rule. But is it
How
possible
did you get the limit h tends to 0 plus that 5h plus 3 minus 3 or something?
Yeah,
Can you
so
explain
3
that?
will be 3 will be cancelled out
No, how do you get the 3 there?
from this. So the value of p is 2, right? That
Okay.
means it is 5x plus 3.
Okay, that is the f of 0, right?
F
Okay.
of h will be
Okay.
5x
Minus,
plus 3.
okay.
Then f of 0 is
0
3.
minus 3.
So
Okay.
3 will be cancelled out. Then h will be cancelled out.
Okay.
Then 5 will be there, right?
Okay, thank you.
So,
Okay.
okay. So is it possible anywhere at any point for any h?
No.
No, right? That means the function is basically not differentiable at 0, right? We can conclude this thing, right?
But yeah, because the LHD is not equal to RHD.
Yeah. So it is basically not depending upon the constant m. So for any m, we cannot say the function is differentiable. So this line we cannot say actually. Okay. So basically we are finding the contradiction. That means for any m, the left hand derivative and right hand derivative is not equal. That means the function is not differentiable at 0. Okay. Any doubt?
So we can't find the value of m.
Yeah. Yes.
But in the question they have given this is differentiable at 0, no?
Yeah. This is wrong. This is wrong. This is not differentiable at 0.
Okay.
I just wrote the question for my mind. So I was thinking it will be differentiable, but it is not.
Ma'am, can we do it in this manner? Like if we take f dash at 0, we'll get the value m.
No. When you are taking f dash at 0 means you are automatically assuming that derivative exists.
Oh, no,
But
this is because in question it was mentioned that it is differentiable at 0.
yes. But
In that case,
it is a wrong information. It is a wrong information. Like the question was wrong. The information is wrong. The function is wrong.
no, if it was correct, I'm just telling you my steps that whether it is correct or not. If it was differentiable at 0, then if I take f dash 0, it will come m.
Yeah, then you can
If
do.
I take
Yes.
if I take the right hand derivative,
Hmm.
f dash at right hand derivative, I'll get 5. 5x will differentiation of 5x will give 5. So
Okay.
if I equate them both, can I take m is equal to 5? Can I equate them?
How can you find the value of m from here? Like if you calculate the left hand derivative, you will have n
E to
e
the
power
power x.
x, and we know the value of n. That means value of n is 1, right? So it is e
Yes.
power x. If you
Yes,
just
ma'am.
calculate derivative, it will be e power x, right?
Yes, ma'am.
And at 0, it is 1. At 0.
Yes.
Right? And if we calculate this will
Okay.
be
5.
5. So these are not equal, right?
Okay, got it.
Okay. That means the left hand derivative and right hand derivative are not equal at that point. So we cannot say that the function is differentiable. Okay. Any doubt, others? So this information is wrong actually. That means it is not a standard question. I just wrote this from my mind. So I thought it will be differentiable, so I wrote it is differentiable, but it is not. We can also check whether this is differentiable or not. So if it were differentiable, then you, like in this way, you can calculate the differentiable, the derivative at that point, then you just equate them and you will get the value of m. But it is not differentiable, so we cannot get the value of m. But the value of n is 1 and value of m is 2. That is what is in our hand using the continuity. Okay.
Ma'am, if we take it x plus p plus 1 instead of 5, if we take x plus p plus 1, then we'll get right hand derivative as
Yes.
1.
Yes. Yes.
Then can we equate m is equal to 1?
No, actually, in that case, for any m, it will be satisfying. Like for any m, the function will be differentiable. Doesn't matter what the m is. For any m, the function will be differentiable.
I didn't get your point, ma'am.
So if suppose this is just x, okay,
Yes.
then for any m, the left hand derivative will be equals to right hand derivative, right?
Okay.
Okay. So this is 1. That means left hand derivative is equals to
Right hand derivative.
for any m. So if m is equals to 1, then also it is satisfying. If m is equals to any other number, then also it is satisfying. So for
Ma'am,
any m,
if m is any other number, like it is 2x plus 3, then we'll get f dash at 0 equals to 2. Then that will not be equal to its left hand or right hand derivative.
what did you say? Can you repeat?
If we take any value of m, like if we take 2, it will be 2x plus 3.
Hmm.
Then f dash at 0 will be 2. Ma'am,
Okay.
2x plus 3, if I derivate 2x plus 3, I'll get 2.
Hmm.
But now this f dash 0 is not equal to its left hand derivative or right hand derivative.
No. See, the concept of derivative is not like continuity. Okay. So if you want to find the derivative at the point, that means it will be equals to the left hand derivative as well as the right hand derivative. So the derivative at the point is basically 1. That is what in our hand is, right?
Ma'am, we have written the definition. Left hand derivative LHD is equal to RHD is equal
Yes.
to f dash a.
Yes.
So if I substitute f dash 0, I'm getting a value of m as 1 only, not any value of m.
No. What you are doing is you are calculating the derivative for this function at 0, right?
Yes, ma'am.
So no. For derivative, we don't do this. Like you are calculating the derivative at that point 0 means first we are calculating the derivative for the general function. Then we are putting 0. So we are putting 0 on the function f dash, not f. They are different function, right? It is like the concept of derivative is not like continuity. It's like when we are putting 0, we are applying 0 on the function f dash x. So first we have to calculate f dash x.
So
At
if
the
f dash
point
x
0,
comes out to be constant,
yeah, it can be a constant, but if it is a constant, then it should be constant for all the cases.
okay.
Okay. Okay. Yeah. Anything else from this question or?
Ma'am, take one more example on this concept.
This piecewise differentiation, please give one more example.
Yeah, sure. Okay, just Pause for some time. I'm writing one more example for differentiability. Okay, suppose this is our function and then find the value of m plus n. Have to use the definition of differentiability. Okay.
Ma'am, it is a differentiable function.
Yeah, it is given that it's differentiable at 0. Have to find the value of m plus n.
So is it 4?
Okay, let us see. Similarly, we will use the definition. So 0 f of h will be minus f of 0 will be 1 by h equals to right? Is it fine up to now?
No, can you please explain the first one? That h cube plus 3h.
So it is limit h tending to 0 minus f of h minus f of 1, f of 0, right? So when you're taking h tending to 0,
Here a plus h, right? What is a is 0?
a is 0. So
Okay.
basically we have f
Of
of
h
h minus
minus f of e, right?
this, right?
Is f of 0.
Yeah. So h tending to 0 minus means we will take this function, and h tending to 0 plus means we will take this function. Okay.
Okay.
In the right hand expression, you will have minus m, sorry,
Minus 1, right?
m, right?
F of 0.
Cos 0.
So you have
Yes.
equality here. So you have to take f of 0 as 1.
Oh, I see, sir. Okay.
Okay. Now we can cancel them out. So what we will get? Limit is 10 to 0. 1 h we can take as common and cancel, right? So we will get 3 plus h squared. Limit.
Explain the right hand side limit.
What?
This right hand side 0 plus limit.
This one. So here again we are using f of h minus f of 0, right? F of 0 is 1, right? From
F
here.
of h m into
And
cos.
h tending to 0 plus means we will take this.
How f of 0 becomes 0 now? But from the previous one.
Not 0. F of 0 is 1.
How?
Here we have the equality.
Okay. From
So
there.
f of 0 means you have to take 0 here, right? Instead of x.
But for f of 0, we should not take this n x, sin x plus m cos x. We should not take that one.
F of h we are taking. Limit h tending to 0. F of h minus f of 0 by h, right?
Okay.
So when h tending to 0 plus means h is greater than 0. That means in this domain. So we will take this function. That is why I write this.
Okay.
Then we have f of 0. Equality we have in this interval. So we will put 0 instead of x here. So f of 0 is 1, right?
Okay.
Okay. So this is what is this. Now in the next step we can write this is fine, right? So here we have n sin h. So if I just separate the h, okay, first we can check the value. So here we have n sin h plus m cos h minus 1 by h. And this is equals to, what is the limit of this function?
We'll do velocity 3. Okay, for 3
Right.
is 3. Yeah.
That means we know that this limit exists, right?
Yes.
So because h is 0, this should be in the form 0 by 0, right?
Yes, ma'am.
If I put 0, so what we will get? N sin 0 plus m cos 0 minus 1 by 0. So it will be basically m minus 1 by 0. So if this limit exists, what should be the value of m?
Infinite.
4.
4. Why 4?
Because the
Quantifiable.
limits are equal, no? Then m minus 1 equal to 3.
We have this
Becomes
limit h tending to 0 of m minus 1. If the limit exists, this should be in 0 by 0 form, right? Otherwise, how can we calculate the limit?
Will be 1.
M should be equals to 1, right? If m is equals to 1, then this is in 0 by 0 form. So we can use the L'Hopital rule in the next step. Is it clear?
okay.
Okay. So if m is not equals to 1, that means it is not in 0 by 0 form. That means we cannot apply L'Hopital rule. But if we cannot apply L'Hopital rule, that means limit doesn't exist. But we know that limit exists. So m must be equals to 1 in order to the existence of limit, right? So m is 1. So we found the value of m. So in the next line, we can write 0 n sin h plus cos h minus 1 by h. Is it fine?
Yes.
Okay. Now we can again write it as h tending to 0 plus sin h by h plus limit h tending to 0 plus cos h minus 1 by h.
Yeah,
right?
you have removed the m, no? Where is the m
The-
from cos h?
M is equals to 1. Na? I just put the value of m in the equation.
It is the assumption or it is the actual value? How do you get
It
m
is-
is 1?
That is what I explained. Na? We know that the limit exists. But
Okay.
if m is, suppose m is not equals to 1,
Okay, okay,
then we cannot define the limit, right?
okay.
So m must be equals to 1 because the limit exists. So it must be in the form 0 by 0. Okay.
Okay.
Now in the next line, I just put the value of m. So we found this. Then we are adding the using the addition rule. Okay. Now what is the limit of this function?
1. N.
Yeah, like only this portion is 1, right?
1.
And what is the limit of this portion?
1.
This is 1, right? Okay.
How it becomes 0? Because cos 0 is 1, right? Sin 0 is 0.
So we can use the L'Hopital rule. This is in 0 by 0 form. If I use the L'Hopital rule, so it will be sine of h minus sine of h by 1. So it will be 0, right? Is it fine now? So
No, I don't get it.
Okay. So we want to calculate the limit of this function, limit h tending to 0 plus cos h minus 1 by h. This one, right?
No, I
So
don't
if I-
understand both.
This is a standard formula, na? Limit h tending to 0 sin h by h is 1.
No, there was one n, no? How do you get rid of that n?
This n is here.
Oh, you
outside.
have taken outside. Okay.
Yeah, outside the limit. So
Okay.
n is dependent. N is not dependent upon h. So it
Okay.
is a constant, right? So if I
Okay.
have a
Ma'am.
constant multiplication, we can take it outside. the
Minus
limit.
1. Cos h minus 1 by e is minus 1. Limit. Cos h minus 1 by h is the limit minus 1.
It will be 0, right?
No, ma'am. Minus.
No, see, it is in 0 by 0 form, right? So we can apply the L'Hopital rule, right?
Yeah.
So what will be minus sin h, right? After applying the L'Hopital rule, this will be minus sin h, right?
But you have written cos h minus 1 as minus sin, huh?
Cos h minus 1 by h, this is the function. Use L'Hopital rule. So what will be the next step? What is derivative of cos h minus 1?
Minus sin h.
Yeah. And what is derivative of h?
1.
So this will be the next step, na? If I use the L'Hopital rule.
Yeah.
So this will be 0, right? Any doubt?
Yes. No.
So this portion is 0 and this portion is n. So the whole limit is n, right?
Yes.
And we have
Yes.
3 here. That means n is
Is
equal
equal to 3.
So what will be the value of m plus n?
4.
Is any doubt? This is a very important question from your exam point of view. So if you have any doubt in any step, Please don't hesitate to ask. Any doubt in any step of this problem?
Ma'am, please
Ma'am,
explain this.
explain once more.
One by one. Yeah.
Ma'am, please explain once more this question.
Okay. So we have the function and it is defined on different domain. When x is less equals to 0, we have some function. And if x is greater than 0, we have some function. We have the hint that this function is differentiable at the point 0 and we have to find the value of m plus n. Okay. Now, if the function is differentiable at the point, that means we know that the left-hand derivative at the point is equals to the right-hand derivative at the point, right?
Ma'am, it means the function is continuous at 0, right?
Yeah. Yes. Differentiability implies continuity. So if it is differentiable, means it will be automatically continuous. But here we will use the definition of differentiability. So the right-hand derivative will be equals to the left-hand derivative at the point. Okay. Now we are just simply applying the formula. Limit s tending to 0 minus f of h minus 0 by h equals to limit h tending to 0 plus f of h minus f of 0 by h. Now,
Ma'am, but at denominator, it should be f of h, right?
why?
According to formula, f of h minus f of 0 upon f of h.
I recall the formula, right?
Yes.
What is the formula?
Oh, okay, sorry.
So, I just applied the formula for left-hand derivative equals to right-hand derivative. Okay. Here are a is equals to 0. So, I'm taking f of h minus f of 0. Now, when f is tending towards 0 from the negative side, that means we will take this function. And if x is tending towards 0 from the positive side, that means we will take this function. Now, simple calculation. Now, after this stage, we have seen that this is in f by g form, right? Our g is 0, h is 0. Now, if I put 0 here, we will find m minus 1 in the numerator. But we want 0 by 0 form because we know that the limit exists. But if this is not, like if m is not equals to 0, that means we have some finite number by 0. That means the limit is not defined, right? But we know that the limit is defined. So m must be equals to 1. So the value of m will be 1, right? Okay?
Yes.
Yeah. So in the next step, I just put the value of m here in the equation. Now we have n sin h plus cos h minus 1 by h. Okay. Now we will use the addition rule and constant multiplication rule because we know that n is a constant. So we will take n outside the limit. So n is here. Then we have limit sin h by h using the addition rule plus cos h minus 1 by h, limit h tending to 0. Now the limit of sin h by h is 1 and the limit of cos h minus 1 by h is 0. So we will just use the addition rule and put, so we will get n plus 0, that means n. And here we have already 3 in the left hand side. So left hand, that means n is equals to 3. Okay. Any doubt?
Ma'am, limit h tend to 0 plus sin h by h is equal to 1.
Yeah. You can use the L'Hopital rule. It is in 0 by 0 form. Then the derivative of sin x is cos x and derivative of h is 1. So in the next line, you will find limit h tending to 0 cos x and cos of 0 is 1. So the limit will be 1.
Okay, ma'am, got it.
Okay. Yeah, anything else?
Ma'am,
Yeah.
can we solve the activity assignment of L Hospital's rule?
What is your doubt? You can share your doubt. I can solve it.
Ma'am, actually, I am not able to approach the question.
Yes. So in which question you have problem? You just share that particular question. I will solve it.
Okay. Question number 3.
I can just take a screenshot and send it in the chat box.
Can I share the screen?
No, you are not allowed to share the screen. You
Yes.
just take a screenshot of that problem and share the screenshot in the chat box.
Okay.
Yeah.
In the meantime, can I ask you a question?
What?
In the meantime, I would like to know about this revision schedule because last week there are some other from the diploma course and there was kind of discussion. After that, I couldn't attend the previous session from 1 to 4 revision.
So there are no other 1 to 4 revision, but
Okay.
the live streaming is there. You
Okay.
can go through the live streaming, and today I just completed 5 to 8, and next Tuesday we will have the revision session from 9 to 11. That means the graph theory portion and the integration portion.
Okay. Thank you.
Yeah.
Ma'am, I have shared one question.
Okay. This one?
It is a composite function. We have to find the domain.
Yeah. So we have the composite function f compose g, and we know that the domain of this function, the domain of the composite function, suppose we have f from a to b and g from c to d. So the domain of f compose g is a subset of c such that a range of G is a subset of A, right? So we have to basically restrict the domain of G such that the range of G becomes a subset of A. Okay. So what is the domain of G? What is the domain of G?
All real numbers except 0.
R minus 0. And what is the range of G? What is the range of G?
Minus
Infinity to infinity.
Sure. Are you sure? Think about it twice. Can I find 0 for any?
except 0.
Yeah. So the range will be again R minus 0, right?
Yes.
What is the domain of this function? F. What is the domain of F?
X greater than 1.
Yeah. That means from 1 to infinity, right?
Yes, yes. That's the common for both the
Yeah.
functions.
2.
0 to
Right? Is it fine? Now we want to find the domain of F compose G, that means we want to restrict the domain of G such that the range of G becomes a subset of this. Okay, so basically we want the range should be subset of this. So that means we have to exclude some point from the range, right? To become to make it a subset of 1 infinity, right? R minus 0 is not a subset of 1 to infinity, but we have to exclude some point from R minus 0 so that it becomes a subset of 1 to infinity, right?
So we have to exclude negative points.
Yeah. So what are the point we have to extract from R minus 0 so that it becomes a subset of 1 to infinity? Minus infinity to 1, right?
Yes, ma'am.
Right? If I just exclude this set from R minus 0, then it will be subset of 1 to infinity. Agree? Agree?
Yes, ma'am.
Yeah. That means we have to exclude this point, exclude the point from the domain for which the image lies in the set, right? That is our target is to exclude points from the domain R minus 0 for which the image lies within the set minus infinity to 1, right? So for which point present in the domain, the image is in the set minus infinity to 1. Hmm? For which point? What is our G? 1 by x, right? For which x? 1 by x will be inside minus infinity to 1. Sorry.
Image is within minus infinity to 1.
Yeah, that means we have to exclude the points from the domain for which the image is inside minus infinity to 1. Is it clear?
Image of the points which we have to remove.
Yes.
Okay.
Because if I remove this portion from the range of G, then we will find the range of the new range of G will be subset of domain of F, right? That is what we want, right?
Yes, ma'am.
Yeah, that means we have to remove those points from the domain of G for which the functional value or the image is within the set minus infinity to 1. That means x, we have to remove x such that 1 by x belongs to minus infinity to 1. Now we have to find the x such that 1 by x is from minus infinity to 1. So what are the x? Hmm? What are the x?
Will it be 1 to infinity only?
If I take any negative number, then first of all, we are excluding the whole negative number system, right?
Yes, ma'am.
Step by step, if I follow. We are excluding whenever x is a negative number, 1 by x will be automatically a negative number, right?
Yes, ma'am.
So we are basically excluding whole negative number system. First of all, exclude whole minus infinity to 0. Okay.
Yes.
Then
It will be greater than 0.
0 to, now we have to check 0
Open
to 1,
bracket
right?
0 to infinity.
We have to check 0 to 1, right? Right?
0 to 1, but subset should lie from 1. Like domain of f is 1 to infinity. So 0 to 1 points will not be included in the domain of f.
No. 0 to 1 means I'm just saying x such that 1 by x is in 0 to 1. We have to exclude them too, right? Those x for which 1 by x is inside 0 to 1. Right?
Yes, ma'am.
Yeah. So negative points we already excluded. Minus infinity to 0 we have to exclude. Now we have to exclude some more numbers so that we can avoid this 0 to 1 portion also, because this is obviously not inside the domain of f, right?
Yeah.
So we have
Got
to
it.
exclude 0 to 1, right? That
Is
means
it
we have to exclude those x for which 1 by x is inside 0 to 1, right?
0 for g of x and 1 for f of x, right?
No, 0 to 1 is 0 to 1 is the interval. We have to remove that interval from the range of g, right?
1 by x will be 0 when x is infinity.
1 by x is 0. Yeah, 0 is not inside the range, inside the domain of g. So 0 is not our point of concern. Okay.
So if it's
This
from
is our
0 to
target.
1.
See, let me just brief it. This is our target, to remove those x from the domain of g such that 1 by x is inside minus infinity to 1. Is it clear for all of you? Is it clear for all of you?
Ma'am, please repeat.
We have to exclude this portion from the domain,
Yes, ma'am.
right? Because we
Yeah.
want this, right?
Yes.
Yeah. So now, if I if we can break this interval in two different way. First, minus infinity to 0, then 0 to 1, right?
Yeah.
This is the set, exactly this set, right? Minus infinity to 0, union 0 to 1, because 0 is not inside the range, right? Is it
Yes,
fine
ma'am.
up to now? Yeah.
0 is already excluded.
Yeah. So we are not bothered about 0. Basically, minus infinity to 0, if I check the interval minus infinity to 0, so if I just exclude all the negative numbers from the domain of G, that means we are done with that interval, right? Right?
Yes.
We want to exclude this interval from the range. If I exclude all the negative number, then 1 by x will not be negative, right? So we are done with this interval. Now we have to only check what are the x's for which 1 by x is inside this set, 0 to 1. Is it clear now? If you have any doubt, you can ask. Is the target clear?
Yes, ma'am.
Okay. So now we have to find the x for which 1 by x is inside 0 to 1. So what will be the x? 0, 1 by x, this. So if I reverse it, what will be? 1 x infinity, right? Right?
Yes,
Yes, ma'am.
That means those are the x we have to exclude from the domain of G. That means now, if I write it briefly, so that means if I exclude minus infinity to 0, union 1 to infinity, this portion from R to 0, R minus 0. Exclude this from. So we are excluding this set from this set. So what will be the remaining portion?
Ma'am, 0 to 1, but 0 and 1 already excluded.
0 to 1. This, right?
But borderline are excluded, right?
Yeah. That is what 0 to 1 open interval is coming. Okay. So this will be the domain of the composite function. Is it fine?
Yes, ma'am.
Any doubt? Anyone? Any doubt? This is the domain. Domain of F compose G. Is it fine? Any doubt?
No, ma'am.
Yeah. Anything else? Okay. So here limit extending to 0 plus. Okay, for the first question, this is in 0 by 0 form, right? So we can use the L'Hopital rule. If I use the L'Hopital rule, what will be the value?
1.
No, ma'am, 0.
0, right? So this will be cos x. And what is the derivative of root x?
1 by 2 root x.
We
That
can
means-
multiply and divide it by root x, no? Then it will come as sin x by x into root x.
Yeah, that is also possible. That is also possible. You can do it in any way, no matters. So we have this, right? Now simply put the value 0 and this will be that. Okay. Next we have this. We can break this function in. So this will be minus x squared if x is less than 0 and x squared if x is greater or equals to 0. Now, if I can calculate the derivative at 0, then it will give 0 at both the point, right? So differentiable on R, okay?
Yes.
And this, not this, sorry, this, right? Right?
So it is x square only, know how it become 2x? Oh, it is f dash.
Derivative,
Okay.
yeah, derivative function. So
Yes,
derivative
ma'am.
function will be 2x when x is less than 0 and 2x when x is greater or equals to 0. Okay. Fine, right?
How do you say f is differentiable on R?
The derivative is 0 from the left hand and right hand, both the side, right?
You have to find the derivative and then we have to apply the
Yes. The left hand derivative and the right hand derivative. You can
at
directly
0.
use, you can directly use the formulas too, right? So if I calculate the left hand derivative directly using the formula, it will be minus 2x and the right hand derivative will be 2x.
But
So
it
at
is
0,
yeah, it is differentiable on all points on R. No, why do you select only 0?
okay. So other than 0, it will be automatically differentiable because other than 0 at any point, it is a simply polynomial function, right? Quadratic function. right?
Okay.
We have to check at the boundary point, and 0 is the boundary point. At the point 0, we are breaking the function. So we will check at 0. So if it is differentiable at 0, that means it will be differentiable at any point.
Okay.
Yeah. So at 0, the left hand derivative, right hand derivative, both are 0, right?
Yes. Yeah.
Yeah, that means it is differentiable, and derivative function we can calculate using the formulas. Okay?
Yes. Okay.
Yeah.
Ma'am,
Yeah.
if we go to previous question, the domain one, composite function. Ma'am, we found the result 0, 1, right?
Yeah.
But it is not a subset of domain of F.
Why?
Because domain of F is greater than or equal to 1, and the points we got was 0 to 1, which were points between 0 and 1.
No. The domain of F compose G is a subset of domain of G. Subset of domain of G such that the range of G becomes subset of domain of F. The domain of G was R minus 0, right?
Yes, ma'am.
The domain of F compose G is 0, 1, and it is a subset of R minus 0.
Okay.
Okay. This is a subset of domain of G. Domain of G is R minus 0, not F. Okay.
Yes, ma'am.
Anything else?
No, ma'am.
Yeah. Any other doubt? I'm waiting for some more time. If you have doubt, you just ask. Otherwise, you can leave.
Ma'am,
Yeah.
theoretically, limit, continuity, and differentiable, how are they related?
Differentiability implies continuity. Continuity implies limit.
It means if a limit is exist and continuity also, then function is differentiable.
No, no, no. If the function is differentiable, then the function is continuous, then limit exists. Reverse we cannot say.
Okay.
Okay. If the function is differentiable, then the function is continuous, then the limit exists at that point.
Okay. Thank you, ma'am.
Yeah, welcome. Anything else? I'm there for some more time. If you have doubt, you just ask. Any doubt?
No, ma'am. Thank you, ma'am.
Okay. Okay, then welcome. Yeah, and Tuesday we will have the last revision session, week 9, 10, and 11. Okay.
Okay, ma'am. Thank you, ma'am. Good night.
Yeah, good night.
10th also, there is one more revision session in the calendar.
Yeah, that is for DAT qualifier. It is again 9, 10, 11. If you want, you can join. But you will have the revision session on Tuesday, the same syllabus.
Okay. Thank you.
Yeah.
Good night, ma'am.
Yeah, good night.